We're going to look at carboxylic acids. So you notice these are at the top of the functional group priority list. They're named with either the suffix oic acid or the prefix carboxy, and they contain the carboxyl group, which is often abbreviated as that COOH. So let's have a look here at just a representative molecule. So we'll make 4 carbons in the main chain. All right. And we're going to circle the functional group, so this right here, the whole thing together. It looks like you've combined an aldehyde and an alcohol. All right, this is the carboxyl group, and it is always carbon 1, because you can notice there that in order to attach it to the main chain, there's 1 bond on the carbon. The other 3 are involved just to make the functional group itself, so it's always carbon 1. It's always at the end of the line. All right, so there's 4 carbons in this chain, so that's butane, and then I add oic acid. It is very common to completely omit the number. All right, so next up, let's have a look at something a little bit more complicated. We'll put multiple functional groups in this one. We'll put 6 carbons in the main chain here. All right, so here's 1 carboxylic acid. All right, let's put a phenyl in. A fluorine, an alcohol, and you know what? Let's put another carboxylic acid in. All right. So you may be thinking, well, how can they both be carbon 1? Well, both ends of this chain aren't carbon 1. One of them will be carbon 1. One of them will be something else. So here, these are both carboxylic acids. So that's the highest priority group. So again, one of those 2 ends has to be carbon 1. The other will be carbon 6. In green, we'll put the phenyl group. So phenyl is number 8 on the priority list. Fluoro is a halogen. That's number 12 on the priority list. And right here we have an alcohol, which I'm going to write as hydroxy because I'm going to use the hydroxy prefix to account for it. Okay, so it's an alcohol, and that's number 6 on the priority list. So I'm already comfortable with the fact that one of the ends of the line has to be carbon 1, but I'm going to start numbering from the right because that puts the alcohol, the next highest priority functional group, at carbon 2, rather than if I were to go from the other side, it would put it at carbon 5. All right, so the correct numbering here would be starting from the right-hand side. So I'm going to go now alphabetical order. 4 fluoro, 2 hydroxy, 4 phenyl, okay, so FHP in terms of alphabetical order, 4 fluoro, 2 hydroxy, 4 phenyl, hexane, all right, because there's all single bonds between the carbons, so hex for 6, and for single bonds, 1,6-dioic acid. All right. Now, the only thing I haven't really looked at is, well, if this is the highest priority functional group, when would you ever need the prefix carboxy? Well, I'll give you an example. Let's take one of our larger aromatics. So we're going to look at anthracene here. All right, let's put a carboxy group, and we'll put a fluorine. All right, so carboxy group to the rescue. Because we know that the anthracene molecule, all right, has an enforced numbering system. So that's going to put the fluorine at carbon 1 and that carboxyl down at carbon 6. So if I am aware of the carboxy prefix, I can simply say 6 carboxy, 1 fluoro, C before F. So 6 carboxy, 1 fluoro, anthracene, done.